Okay, today we are learning about how to show that a quadrilateral is a parallelogram, section 8.3. Now, yesterday what we learned about was the properties of the parallelogram. That's what we learned about yesterday. But what happens if we don't know if the parallelogram is indeed a parallelogram? We just know it's a quadrilateral, but we don't know if it's indeed a parallelogram. Well, we're going to use kind of the same properties that we learned yesterday, but we're just going to work them backwards. If we can prove 5 different ways, show 5 different properties, then we can prove that we have a parallelogram. So what I'm going to do is I'm going to write down each of these ways right here on this board, and that's how we're going to show how a quadrilateral is a parallelogram. So the first thing we learned is that both pairs of opposite sides are parallel. That's the first way. Now, do you remember how to show the symbol for parallel? Yes. We're going to use the little triangle, shading the triangle like this. Okay. All right. Now, since it says both pairs, we're going to go ahead and do this as well on both segments. Remember, CD, AB are opposite sides, so that means they're showing that they are parallel. AD, BC are opposite sides, and we have shown that they are parallel. Okay? Now, what else have we learned? We also learned that both pairs of opposite sides are congruent. Okay. All right. So, how do we show congruence on parallelogram? That's right. We have to just mark it off using gold dashes. So, since I used one mark for parallel on these two sides, I'm going to do one mark of congruence on those sides as well. And then since I did 2 right here on each of these, they're opposites, I'm going to mark that, okay, twice. Now, basically, when we did this yesterday, we learned that we put both these things together, all right? However, these are separate ways. So if I can prove that opposite sides are parallel or opposite sides are congruent, both pairs of them, then we can say that the quadrilateral is a parallelogram, okay? Now let's think about some other things we learned. We also learned about angles. We learned about the opposite angles, like A, C, B, D. All right? And here's what we have to remember. We have to remember that both pairs, let me jump over here again. Both pairs of opposite angles are congruent. Okay? And since we're talking about angles, we're going to go ahead and mark that. So I'm going to mark this parallelogram. Here's angle A. Opposite angle A is angle C. So we'll mark that, one mark. And then, since B and D are opposites, we don't know they're equal to A and C, so we're just going to mark that twice. Mark each of these twice. Okay? So if we can prove that both pairs of opposite angles are congruent, we have also proven that the quadrilateral is a parallelogram. All right? The fourth step is that if I can prove that one pair of opposite sides are congruent and parallel, then I can prove that the quadrilateral is a parallelogram. So we're not have to worry about both pairs, we just have to worry about one pair. So we can prove that they're both congruent and parallel, and I'm gonna go ahead and highlight the word and. All right? So if I can prove that, like for example, if I can prove that AB and DC are both congruent and parallel, then we have proven that the quadrilateral is a parallelogram. All right? Now, there's one more way that we can use, and the way is this. I can prove that the diagonals, or if I can prove that the diagonals bisect each other, okay? If I can prove that the diagonals bisect each other, then I've also proven that the parallelogram is there. I've proven that the quadrilateral is indeed a parallelogram. So remember how we draw the diagonals. Let's draw it like this. Now remember, bisecting each other means that, for example, from here to here, and we'll call this point M, from D to M and M to B, those are congruent. All right, that's showing bisecting. So I'm gonna go ahead and mark this 3 times to show that they're congruent. And from A to M and M to B, we'll mark that separately as well. M to C, excuse me. A to M, M to C. All right? So if I can just take any of these ways, any of these 5 ways, and find a true statement out of this, then I've proven that the quadrilateral that's presented to me is a parallelogram. So what we're going to do in a moment is show you indeed a problem that we can use maybe one of these or perhaps more of these to find the problem, to find the answer to that question. All right? So let's do that.